Hello, this is Tanner Taylor, and I'll be showing you my project, my final project. Here's a rough layout of my project. It is a tank system with a PID loop that will maintain water level based on your set point. I'll put this back down to 14, which is this green mark right here. You have the ability to set it, but we'll get into that later. But no matter how open or closed your discharge valve is, the water level will maintain this set point level. So to get into this, I'll show you my program for the start. I used a messaging system between my micrologics and my compact logics because my compact logics has a higher processor that is capable of more power and processing power. So right here you see this is my micrologic. These are all my physical inputs and outputs that are being sent to my compact logics. So you see here you got E-stop, stop, start, hand, auto, red light, and yellow light. And then you go down here, I have my analog values. So this would be my flow meter, and here is my tank level. And that is being all sent over here for my main program in my compact logics. So to start out, I'll show you my main routine. Here's my JSRs, so just different subroutines I've made to help organize myself. Here I got my start process, interlocking alarms, and PID. We'll get into that later. As we go down here, you will see I have a timer. This timer just sends my messaging back and forth between my micrologics and compact logics every 200 milliseconds. And these are just different, my analog, my inputs, and outputs down here. If you go down, I just have some scaling rungs for water percent and my set point. So I have it in percentage instead of inches. So if you go down here, this is my alarming system. And so here's my analog value for my water level. This is in inches, and I created low and high deadband. So I have a deadband of 4 inches that my system needs to maintain before it throws an alarm. That alarming is based on these deadband values. So if my water level is above my high deadband for 12 seconds, it will activate my high alarm. If my low deadband, if my water level is below my low deadband, it will trigger this watchdog and set off my low alarm. Then here I just have basic interlocking. And this is just used for like my low can't be set above my high, and my set point can't be out of range. So if I have a tank level of 30 inches to 0 to 30 inches, it can't be set within out of those values. Here I got my PID loop, and so I have my tank level coming in as my process variable, my control variable being my frequency command. And then you have my set point in inches, which is 14 right now, and my process variable, what it is right now, and my output percentage. And then here's just a timer that motions this every 100 milliseconds. If you go down here is my start process. And then, so I created an HOA, so it sends values to based on this value right here. This HOA tag, it's either an auto, off, or hand mode. And then here you have physical and HMI stop buttons, E-stop circuit, physical and HMI starts, and then your machine enable. Right here is just how my logic to start my VFD. And then if you go down here, I have indicators. So this is my light. Or this is what stops my VFD. And if you go down here, this is flashing for my alarms for this red light right here. So if it's off, it'll be solid, or if one of my alarms is triggered, it's going to be flashing at a rate of 1 second on, 1 second off. You go down here, here's my logic for my jog feature. So it has to be equal to 0 in order to be in jog mode, and you have your buttons, so physical and HMI, to jog. Your VFD, which controls my pump. And then here are just my values for my HOA tag. So this just sends a trigger down there, and it will put a 2 into that destination, or depending on what it is. In this case, 0, making that hand mode. And this is for your physical buttons. And then here you have your HMI going all into the same tag for that mode, because they're the same. And you go down here, this is what initiates your hand, auto, or off, depending on if these values are equal to, so if 0 was equal to 0, hand mode would be on, or if 1 equaled 1, your auto mode would be on, and so on. Then here I just have a little dividing function for my output frequency to put it in hertz, because in your drive it is in the thousands place. So I divided it by 100 so you'd see an actual value that is understandable. So here I'll take you to my HMI, and we'll start with the login page. Here's your login page. I'm logged in as a supervisor right now, and you have the choice to be a supervisor, operator, or janitor, and that gives you different access levels on these pages here. Right now we'll just leave it in supervisor mode so we have full access. So I'll click the systems info page, and this gives you a basic rundown, so gallons per minute, how much your pump is putting out right here, and your water level in inches. We're at 8 inches right now. Water level percent, which is 31%, and then your set point, what your water level wants to be, your high and low values for that alarming feature, frequency, RPM, if your VFD is running, faulted, and then the status of your machine enabled. Right here you just have your set values for your PID function. And now we will go to the main page. Right here you have all those basic layout features that were in the systems info page, but now you have more control. This is for operator supervisor level. You can set these set points, these alarm values for your high and low, or you can adjust your PID loop to make it more efficient. And then you have all your control functions, start, stop, auto, off, and then those values. And then you also have the ability to reset your VFD if it is faulted. So right now we'll go into hand mode, and we'll jog the pump. As you see, it's set to 30 hertz for the frequency, and then you can set that higher or lower depending on what you want. I just did 30, you see my water level going up, and basically just to jog the pump in case you need to test it or anything else. We can put it in auto mode, and as you see, my pump is now at 60 hertz, so it's going to fill that water as fast as it can until it gets to this set point level, and then you'll see it start to slow down because it's almost at that level, and stop. Or it will start to slow down to where it's not pushing as much water, and it's about at that level as you see. And then that's why I kind of did my dead band, because you'll never really be right at 14. You'll be a little bit below or maybe a little bit above. So that's why that dead band is there. So now we'll go to the alarms page. You see now I had an alarm because earlier I was below my low set point. And then you have the ability to clear, acknowledge all, you can scroll through. Right now we'll just hit acknowledge, and Now that alarm is dated and posted and in your history. So right now we'll go to the main page and we'll set this set point, or actually we'll hit off real quick. Escape. We'll turn it off. We'll set our set point at, let's just say 18, which is 4 more inches. My set point raised, we'll just leave my values here, and we'll hit auto and then start, and we'll go into the trims page so you can see how this works. So right here is my red, which is my set point, and here's my water level. You can see my water level is raising to that set point as quick as it can, and it'll start to level off once it reaches about to that point. As you see, it's leveling off now. My water level is at 17, set point's at 18, and it's gradually working its way up. And that's about it for my HMI. We'll just go back, hit off, shut everything down, and we'll go to my drawings. So here's a basic rundown of my drawings. Right here you have my VFD, my 3-phase going into my VFD, then I have my motor contactor, and then the motor or pump itself. And then right here you have my 24-volt side going to my E-switch, my panel view, and my PLC. Here you have my analog cards, which are, here's my pressure sensor, and then it shows you leads, like orange goes to your input, blue, common, brown, voltage side. Then here you got your flow meter, which is the same concept as the one before. And then here you have my VFD setup. So this shows my physical setup, but right now I'm not using it because I'm using it over Ethernet because it's a lot easier to change the settings in your frequency drive instead of going through all those parameters that you don't even know. This shows the label of each parameter and its value, and you can change it. But I also have this set up as well. So you have your e-stop circuit for your safety, and then you have all your outputs right here, inputs and outputs. Yes, thank you for watching, and that's my project.